Greetings and welcome to this presentation on storage tank management. This is one in a series of presentations on the operation, maintenance, and management of water and wastewater utilities, designed for operators as well as managers of utilities serving Native American tribes and Alaskan Native villages. This presentation provides an overview of the main operation and maintenance tasks related to storage tanks used with public water supplies. We'll discuss a number of issues related to storage tanks during this presentation, starting with why we need to store water. This will be followed by a brief description of the types of storage tanks that you might encounter, and for each type of tank we're going to provide inspection and maintenance recommendations. And finally we'll present some of the ways that you can protect your storage tanks. Ongoing protection and maintenance of your tank is very important because, as you know, it's a significant part of your water system. So we'll talk about protective measures for corrosion control and cold weather considerations for those who operate their systems in areas where temperatures fall below freezing. A question: why do we want to store water? Well, for one thing, your supply and demand are not equal at all times. If everyone's using water at the same time, you're going to see a large spike in the water demand. For example, if you have an industrial client that requires a lot of water at a certain time of day, it may be more than you can provide from your well or your surface water source or treatment plant. So having a storage tank helps you equalize your supply to your demand. There can also be economic benefits to having storage tanks. In terms of power savings, you can have a storage tank, you potentially reduce your pumping rate during times of peak use. With a lower pumping rate, you can use a smaller pump with less power demand. If your system has an elevated tank, you may be able to use gravity feed for much of your system. So once your water is pumped up to your tank, the distribution system can then flow by gravity without the need for additional pumps. Also, by having a water storage tank, you may be able to run the pumps at times when your power company may offer off-peak charges. Storage tanks also help meet high demands during emergency situations. During a fire, there's typically a large demand for water in a very short amount of time. Having the storage tank helps provide sufficient water during that peak need. There are many other unusual times where demands may change. If there's a water main break that occurs or during a power outage, storage tank can provide the additional water and provide surge relief. If you start or stop your pumps on a regular basis as people turn on their faucets or turn them off, you're going to be putting a lot of stress on your system that may result in damage or more wear and tear on your pumps due to increased use or water hammer. And having a water tank mitigates this potential damage threat. In addition, if you don't have sufficient chlorine contact time in your system, and your tanks are located immediately prior to your distribution system, you might be able to use those tanks to increase chlorine detention time. And other advantages include the ability to blend water from different sources or wells as needed. Now we're going to discuss the different types of storage tanks that you might run into with your system. The first type we're showing here is an elevated tank, which is usually a steel tank supported by a steel or concrete tower. Elevated tanks have the advantage of providing both water storage and also pressure or head for your distribution system. Since the tank is elevated, the pressure head between your tank and the rest of your distribution system allows you to provide adequate water pressure to your customers. Another type of storage tank is a reservoir. Those can be located both above or below ground and will typically have a lower construction cost than an elevated tank. One of the downsides to these tanks is that they require a pump station nearby because you're not getting that pressure advantage you would get with an elevated tank. An upside to these is they're less visible. Standpipe is another type of water tank. As the name indicates, it looks like a standing pipe. The definition of a standpipe is a tank with a height greater than its diameter. As you can see in both of these images, the upper part of the tank will probably provide the water system with adequate pressure, but not the lower part. This means a lot of these tanks are still associated with pump stations that will allow an operator to boost the pressure to the distribution system. Another type of tank is a pneumatic tank, often called a pressure tank. Pneumatic tanks provide distribution pressure in place of an elevated storage tank and are typically used by smaller systems. Individuals have private wells at their house may have a small pressure tank in their home in their basement. And these pneumatic tanks typically provide a reliable water pressure for residential customers. And a disadvantage is that they're not great for fire protection because they don't provide a lot of water in a short amount of time. And as you can see from both of these images, they can be stored either above ground or below ground. And next we'll talk about inspections. We'll talk about what you need to inspect and how often this should take place, what you're going to want to inspect at least annually or after any natural storm event. An example would be an earthquake, and that sounds pretty obvious. Or if you've had a large rainstorm, there may be some flooding, and it'd probably be a good opportunity for you to inspect your tanks and make sure everything's looking good. So a few questions for the operator of the system or the management of the system. What are the things you'd want to inspect? Well, in general, you'll have two different types of inspections. General inspections that are performed for all kinds of tanks, and then tank-specific inspections, which we'll get into over the next few slides. So who should conduct a water tank inspection? Should it be you as the operator? Should it be the manager or someone else at your utility? Should you hire a professional? Well, in the case of an elevated tank, an inspection could be both dangerous and specialized, and it may be best to employ a professional or qualified firm to do a tank inspection. This professional will typically submit a report to you, the system owner, with the conditions of some of the things that they have inspected and suggestions on repairs that you may want to make. If you have ground level reservoirs, your annual and periodic inspections may be within the capabilities of your staff, so you wouldn't necessarily need to hire a professional. Or if your water reservoir or tank is emptied for interior inspection, you would want to consider using someone who has confined space training or other special safety training. If you're sending workers in the tank, you want to make sure that there's enough air, there's adequate ventilation, and adequate air quality for them to breathe properly. You also want to provide security and fall protection for the ladders and make sure there's sufficient lighting. During the tank inspection, you should look at the different elements of your tank, starting all the way at the bottom with the foundation. So basically, you're going to start by determining if the physical components of your tank are functioning as expected. You should also perform water quality testing to verify that your tank is providing good water quality, and check the accuracy of the water level indicators as they're needed to manage water demand. When looking at your foundation or containment structure, you may want to check for these 4 items. Did you have any subsidence or uneven settlement? Is there corrosion in the base or any cracks in your foundation? And note any other types of deterioration. You can measure the size of a crack and record that and compare it later to see if it's getting worse and is in need of repair. And always take good notes and write down your inspection results when inspecting your tanks. Overflow pipes and valves are certainly an important accessory for all tanks because they allow the tank to release excess water in the event of buildup in the system pressure that overfills the tank. For example, if excess water in an elevated tank can't exit through the overflow pipe or valve, the excess water will flow out through the vent. Well, in cold weather, the water may freeze and clog the vent, and excess weight from ice buildup could be sufficient to potentially cause your tank to collapse. Making sure that these pipes and valves are well maintained is critical to your system performing correctly. When inspecting these pipes and valves, there are a few things to consider. Are they large enough that they will empty your tank and provide sufficient flow and pressure release? Are they in good condition? There should be a screen on the overflow or exit pipe. Check that that screen is not damaged or deteriorated over time. The screening is important to avoid the entrance of animals or insects building nests that could clog the pipe or valve. As for drainage, make sure that there is a splash plate on the ground or another form of erosion control, such as riprap or stone, to ensure that the soil around and under your tank doesn't erode when water is discharged. The altitude valve, or pressure reducing valve, is a valve that controls the level of water in your tank. And you can see a picture of the altitude valve on this slide. Typically it remains open when the tank isn't full, and it will close when the tank reaches its maximum height or level. You can set your altitude valve to close at a preset maximum water level to prevent overflow, and open again to refill when the water level in your tank or reservoir lowers. An inspection of your altitude valve will be similar to the overflow. Is it sized adequately? What's its condition? And is it working properly? Interior and exterior coatings in your tank are important for steel reservoirs or tanks. When steel is exposed to oxygen and moisture, it'll corrode, as we all know. If you think about your tank's exterior, there is a relatively uniform environment, but on the inside you may have some pretty severe conditions such as ice building up and scraping the sides of the tank, or corrosive conditions depending on the quality of your water. So it's important to inspect both the exterior coating, as shown in the top picture, where the tank is clearly in need of a fresh coat of paint, and the interior coating, where problems can be less obvious. This interior coating will be in contact with your drinking water, so you should make sure it complies with NSF international standards. This inspection will ensure that the coating doesn't impart any taste or odor to your water, and that it doesn't release any harmful chemicals. The steel tank coating is covered under the American Water Works Association standard D102-97. And if you have an older tank, you may want to think about having the paint tested for lead before any work is done or paint is removed. Over time, sediment and sludge will likely accumulate in the bottom of your storage tank, and this buildup can contain bacteria and other contaminants and should be cleaned out of the tank periodically. Your elevated tank must include a drain connection so that you can use it to empty it for maintenance and repair. As is shown at the photo or figure at the top of the slide, you can install a hydrant, which is a common method of draining. It's located on a pipe at the base of the tank as it exits. If you're using a hydrant to drain your tank, you want to make sure that your discharge from that hydrant is not causing any erosion or creating a cross connection. If you've heavily chlorinated your water in your tank for disinfection, you may want to consult environmental officials in your area about acceptable disposal methods for the water exiting the drain or the hydrant. And the bottom or the last few feet of water in your tank should be pumped to waste using portable pumps or a vac truck or other methods. And again, the disposal of the sediment at the bottom of your tank may be subject to local regulations that could require you to first dechlorinate the water or remove it to an appropriate site. Again, you're going to want to check with your local environmental officials. Water level indicators in your tank also need maintenance, mostly to assure that they operate properly and that they give you the appropriate reading. There are different types of water level indicators, which include pressure gauges that will read in pounds per square inch or PSI, or maybe feet of water. For those gauges, you should just make sure that it gives you an adequate reading for your tank height. For float style indicators, if you have those, make sure that you don't have any issues with the cables, that the float moves freely, and again, that the reading is adequate. SCADA systems should be calibrated as necessary. Now, there are a couple issues that may arise with the roof of a tank. If you have uneven roofs with low spots, you may have water ponding, and that will create issues such as holes along the tank seams, among other things. And for safety reasons, if you have an elevated tank, as mentioned before, you may want to hire a professional for inspection of your roof. And it may sound a little counterintuitive or even unpleasant, but the best time to inspect your roof is during wet weather, because that'll help verify that there is no leakage into your tank. With the exception of pressure tanks, all tanks have an air vent that basically allows the air to come in and out of the tank as the water rises and falls. This is intended to alleviate any pressure issues. If an air vent becomes blocked, water draining from the tank could form a vacuum on the inside, and that may be sufficient to collapse the tank walls, causing a catastrophic failure. So therefore, make sure you inspect the vent regularly for any type of blockage. And again, make sure the vent opening is screened to keep out animals or insects from the tank. And when you select a screen or a mesh size, you want to select that mesh size small enough so that you keep the animals out, but large enough so it won't become a problem or become frozen or blocked during freezing temperature situations. Access ladders. These are going to typically start from about 8 to 10 feet above the ground. And as you can see from the left-hand photo on the slide, the distance from the ground is going to help deter any unauthorized access. If you add a lock or a gate at the bottom of the ladder, this will make it that much more difficult to get onto the ladder and access the tank. And your ladder must also have safety devices that are in compliance with OSHA, or the Occupational Safety and Health Administration. One of the safety devices is a safety cage around the ladder, as you can see from the photo at the bottom left of the slide. Another method is to use the safety rail system onto which a worker climbing onto the ladder attaches a safety line. This line would ride on the rail up and down while the worker climbs up and down the ladder, as you can see on the picture on the bottom right. But if there's a quick downward movement in the safety system, it'll have a locking pawl that engages and notches into the rail, which will hold the worker back to avoid a fall. All storage tanks should have hatches installed, both to allow access for inspection and to allow for ventilation when workers are inside the tank. Typically, a roof hatch will be designed to have a raised border or edge around its outside, as you can see, on the left-hand side of the slide. This is intended to avoid runoff or rain from entering your storage tank. And elevated tanks with a large diameter riser may have an access hatch near the ground level, as you can see from the picture on the right-hand side of the slide. That'll typically be made out of steel so as to withstand the pressure caused by the weight of the water within the tank. Hydropneumatic tanks, as mentioned before, can be dangerous if they're not inspected and maintained adequately and regularly. Since they're under pressure, without regular inspection and maintenance, they could fail catastrophically. With these tanks, if you're not qualified or licensed to do the maintenance, you should not work on your hydropneumatic tank. You should call a specialist or a professional. Inspections should include the pressure gauge on the tank to ensure that it's working properly, and the air to water ratio within the tank should be maintained within proper operating limits. After your tank is built, or after any maintenance or repairs, you should clean it and disinfect your tank to make sure that it's safe for drinking water use. The way you could do this is by adding chlorine to the water, either to the water that's used to fill the tank, or by spraying the interior walls of the tank. For smaller tanks, it's easy enough to add a larger dose of chlorine to the water used to fill the tank. This helps maintain a chlorine residual of around 50 milligrams per liter for usually at least 6 hours, and preferably 24 hours. Once the disinfection process is completed, you can carefully dispose of the water. But if you have a larger tank, perhaps over 1 million gallons, the process is not efficient and could be costly in chemicals and interrupt operation. In that case, what you could do is spray the walls with a jet of water containing a chlorine residual that would be higher, maybe around 200 milligrams per liter. And once the tank has been sprayed, allow it to stand unused for approximately 30 minutes before filling it. The tank can then be filled with distribution system water that has been treated with chlorine to provide a final residual of around 3 milligrams per liter. This basically allows you to treat your larger storage tank without having to use a large amount of chemicals or drain the tank. Be aware of safety precautions. Whenever you're dealing with chlorine, you're going to want to make sure that the operators who are doing the spraying are wearing a self-contained breathing apparatus, because the chlorine fumes of the spray water can be hazardous. Some of the steel tank issues you'll encounter are very similar to those encountered with steel pipes. In the photo on the slide, you can see that the roof of the tank corroded enough that there are holes and you can actually see daylight through the holes. This is probably an example of a tank where the repair and replacement of protective coatings hasn't occurred as frequently as it should. And again, in these tanks, you should consider the potential that lead paint was used in the past as a coating, and if so, you should hire a competent person who is licensed to remove and dispose of lead paint. The most important thing here is the corrosion damage. And the best way to avoid that damage is to make sure that you have protective coatings and that they're well maintained. If your tank is experiencing corrosion damage, you may be able to repair or replace some of the hatches or parts, and also repair the pitting. This will enable you to prevent any leaks and maintain structural integrity on your tank. Concrete tanks are pretty durable, and the concrete itself is not going to rust or corrode, but the reinforcement or rebar will. This is evident in both the photos on the slide. If the exterior or interior of the tank isn't maintained, corrosion or pitting in the concrete can expose the reinforcement or rebar and cause it to corrode. You're also going to watch for leaks in concrete tanks, make sure they're repaired, and pay attention to potential cracking or pitting over time. So we've been talking about protective coating and avoiding corrosion and making sure that that corrosion doesn't damage tanks. But, in essence, what is corrosion? Or why does it happen? Well, a corroding tank is like a battery, which has an anode and a cathode, sort of like the red and the black connections in your car battery. The electrons want to flow from the negatively charged anode to the positively charged cathode. In your storage tank, it's essentially the same, where the steel wall of the tank is the anode and it gives off the electrons that flow into the water or the cathode, causing corrosion. So, what do? Well, the corrosion of your tank can be prevented in a couple of ways. You can coat the inside of the tank with paint to provide a barrier to prevent the electrons from traveling away from the steel and into the water, as you can see on the top right hand of the slide. Another option is what's called cathodic protection, and that's introducing an electrical current from an external source. As you can see in the bottom left-hand side of the slide, you can insert a power unit that creates an artificial anode, and in that case, the electrons from the steel walls will be less likely to move to the water. These cathodic protection systems are an economical alternative to periodic repainting and associated downtime for repair, and they're fairly inexpensive. However, the area of the tank above the water line is not protected in that case and can still corrode. And the bottom of your tank may be covered with silt or debris or sand at varying depths, at which point the tank is no longer protected there either. So, the ideal type of corrosion protection is the combination of both concepts, painting and cathodic protection. As we discussed earlier, the proper functioning of the overflow pipe is particularly important in freezing weather. If excess water flows out of the vent at the top of a tank, it will freeze and cause excess weight from that frozen water, and it can be sufficient to cause the tank to collapse. In colder climates, the riser must either be protected from freezing or be large enough in diameter so that it can partially freeze around the outside but still allow flow in the center. A riser of a multi-column elevated tank is often 6 feet or larger. An advantage of this single pedestal tank design is that some heat can be provided inside the column to protect small diameter risers from freezing. Freezing of ground level reservoirs is typically not an issue because the water picks up some heat from the ground where the tank is located. It's normal for ice to form around the walls of the tank, and it usually will not damage the structure. But it is important to keep thick ice from forming on the surface of the water. This is usually done by keeping the surface of the water inside the tank moving up and down by varying system pressure. So each time the tank level is raised, warmer water is brought in. Another method is to utilize proprietary water mixing technologies, which can be purchased and installed to keep the water moving. Some of the utilities in northern areas also drain some of their reservoirs or tanks during the winter because they're not needed due to decreased water use, because nobody's watering their lawns or filling their pools at that time of year. This does simplify winter operation, but then creates a job of having to disinfect the reservoir or tank before turning it to service in the spring. We want to avoid the tank from being frozen solid because it will damage the structure and it'll be very costly to have thawed and repaired. This concludes this presentation on storage tank management. Thank you for listening, and please take advantage of additional presentations on water and wastewater system operation and maintenance included within this training series.